Oh, college algebra friends. All right, so now we're getting into chapter 4. Chapter 4 is polynomial functions. And I know you know all about them, so I pre-wrote stuff and I will just put some things in. So the three important terms that you need to know for today at least, and probably tomorrow, are degree, leading coefficient, and leading term. So we're going to try to answer those questions or, define those things. So degree. When we talk about the degree of a polynomial, it's the highest exponent. Okay, now if there are more than one variable, there's different things, but we're only going to have polynomial functions with one variable, so it's the highest exponent. When we talk about degrees, it's the highest exponent, okay, of the variable. All right, so that's when we talk about degree is the highest exponent of the variable that's in the equation. The leading coefficient is the coefficient of that term that has the highest degree. Okay, it's the coefficient. Now, most of the time if we put them in standard form, it will be first, which is why it's called leading coefficient. But this is the coefficient of the variable with the highest exponent. Okay, the one that gets to decide the degree. The coefficient of the variable with the highest exponent. And then the leading term is, of course, the term, which is the whole thing together, the coefficient and the variable with the highest exponent. Okay, so that's the first. If in standard form, it's the first one. That's why we call it lead. In standard form, and you remember standard form, that's when you put like x to the fifth, then x to the fourth, then x to the third, x to the second, and all the way down. In standard form, it's the first one. But remember, be careful that they're not always written in standard form. Okay, so you will look for the one with the highest degree. Okay, all right, so this is how your book talks about a generic polynomial. P to the x is equal to a sub n x to the n plus a sub n minus 1 to the n minus 1, and so on and so forth. So n, these n's up here, n minus 1, n minus 2, that just means the highest degree is first, because n is bigger than all the others. And then the a sub n here in the front, that just means the coefficient, the leading coefficient. So this is going to be my leading coefficient. Let me see if I can change colors without turning it off. So this is my leading coefficient. Okay, because it's the first one, the one with the highest exponent. Okay, so that's my leading coefficient. And then a sub 0 or a sub naught, whatever you want to say, that's the last one. That's the term that has no variable. Okay? And one of the things to notice that coefficients are real numbers. We don't have any imaginary numbers. They're only real numbers. And exponents are whole numbers. Whole numbers are things like 1, 2, 3, 4, 5, 6, 7, or 0. But anything to the 0 power is 1, so we don't usually have that. So they're the whole numbers. All right, so here are some examples of polynomials that I wrote out for you. So p to the x is equal to 5x to the 17 plus 2x to the 15 minus 3x to the 14 and blah, blah, blah. You can read all of that yourself. Notice I put that in standard form. So the 5 is my leading coefficient. This is leading coefficient. I'll use LC for leading coefficient. And the degree in this one, the degree would be 17. That means it's got a chance to cross the x-axis 17 times. All right, so some simpler examples, some things that we might actually encounter in our work is these two. And notice they're also in standard form. So this is my leading coefficient. And for this second example here of the simpler ones, my leading coefficient is understood to be a 1. So those are my leading coefficients, okay? Both of these are my leading coefficients. The first example, the degree is, 3. And the second example, the degree is 2. Right. So those are the different examples. Now sometimes we write them like this. And this is a nice way to write them because this tells us what our roots are. Okay, so I know that this first polynomial, this one right here, I know that it's going to cross the x-axis at -2 and at +9. That's what I know because that's how that's shown right there. So this one down here, that -2, is just a way to, that's my a, part of my a, my leading coefficient. So this one is going to cross the x-axis at 5 and at -1. Okay, and those are some things we'll talk about in another video. Here are some not polynomials, because you're like, well, what is not a polynomial then? Well, notice this first example here, the x is in the denominator, which means it has a -1 exponent, so that's no go. X to the -2, that -2, remember they're supposed to be whole numbers, 1, 2, 3, blah, blah, blah. The square root of x, that's an exponent of 1/2, if you remember that from the old days. So that doesn't work. And then both of these here, x to the 1/3, x to the 1/2, neither one of those is a whole number, so that's why they aren't. Okay, so now we're going to get into some basic shapes, and I'm going to go real fast through this, but the next video I make is going to be more in-depth about basic shapes, okay? And these are kind of important. You need to be able to identify from a graph what it is. And the most important thing is that leading coefficient. With the first degree, the linear ones, we know that m, our slope, is our leading coefficient, right? mx plus b. M is all about the slope. I'll write that down here. It's all about the slope. And we know that when a line, that's my leading coefficient in this case is equal to m, and that's my slope. We know that if it's a positive slope, when m is greater than 0, our graph looks something like this, right? Some sort of line. I don't know where it's going to cross, but I know it has to be in that direction. And when it has a negative slope, then I know that my line is going to go this way. Okay, and we talked about that before. Those are some things that you should know right off the bat. With a quadratics, remember those are degree 2's because of the x squared, the 2 there, that's the leading term. So a is my leading coefficient, so I'm going to look at a, and we know that when a is positive for a quadratic, that the parabola opens up, right? So it opens up this way. And this one, the quadratic, is the a is negative, the leading term is negative, so it's going to open down. Okay, the leading coefficient tells us all about the direction that it opens. It doesn't tell us how many times it crosses the x-axis, it just tells us which way it opens. Now a cubic is supposed to, well, it has the ability to cross at least 3 times, okay? Now, when a, the leading coefficient, is positive, it's got to sort of kind of look like this graph here, where it starts in the bottom left corner and ends in the top right corner. Okay, so when I have this graph here, when a is positive, it's got to start down here in the bottom left corner. So I know it's going to come in like this. It might cross 3 times, and it's going to go out like that. Notice if I squish it kind of all together, it's going to be the same way that a line goes in that direction. All the odd ones are like that. All the odd ones, that if it's positive, it's going to start in the bottom left corner and end in the top right corner, just like a line does. And then if my a is negative, it's going to start in the top left corner up in here, and it's going to, I don't know exactly what it does, but I do know that it's going to end in the bottom right corner. Just like a line with a negative slope would start in the top left corner and end in the bottom right corner. Okay, so kind of think of it as a line. All odd ones are like that, and we'll talk about more of that in the next video. Okay, so that means the even exponents, the even degrees, they're going to act like the parabola. Now we know that a fourth degree could possibly cross the x-axis 4 times. When a is positive, it's going to start acting like when a is positive for a parabola, which means it's going to start here in the top left side and do its business, and then it's going to end up in the top right side. So it's going to open up, basically. So it's going to cross 1, 2, 3, 4, and then it's going to go on its merry way. Notice that's just like what the parabola does with a positive a. It opens up. So fourth degrees, sixth degrees, etc., etc., they act like the parabolas. So hopefully that will be easy enough for you. So same way here, when a is negative, it's going to like open down. So it's going to start in the bottom, and 1, 2, 3, 4, maybe it does something like that. I really have no idea, but I do know that it's got to start and end like an upside down parabola. So kind of keep that in mind. I'm going to make another video specifically about graphs. And so make sure that that makes sense to you. If you have to look at it again, then look at it again. But if you know how the linears and the quadratics act, you'll be able to tell me how any of these other ones act. Not necessarily where they cross the x-axis, or even if they cross the x-axis, but you'll be able to tell me where they start, in which corner do they start, and in which corner do they end. Okay? All right, so I'll